Hi to everybody. This is Jordí Binefa. And first of all, we can go directly to the material that there is in the web page. And I do a suggestion that is, if you can go to the first link of links to snap codes, and then you can press the green flag. You can write here in this text something. Now I am sending this, and I suggest if you can send your name. I write Jordí, and then now I get Jordí. If you can send for yourself your name, then we can see that you have have access to the web page, and then it works with this board. Okay, here there is the slides, the first part and the second part of this presentation. If we start with the first slide, this is educational experiences with open source hardware and Snap. I designed these two boards. S4A, that means a Scratch for Arduino, or Snap for Arduino programming learning board, and the IoT02 that is thought to teach Internet of Things. This is just, you see, an exam of last May of my students, and is projecting here just an elevator, and they should control the elevator from the boards, IoT02, or from the programs that of the exam. In this part, there are students of a city close to Barcelona, Bellvitge, Hospitalet Bellvitge, and the students are able to use these boards just to do some kind of prototyping of domotic homes. And these are my students, and that are learning how to program embedded devices. And we start with Snap for Arduino just to control how this board works. This is just a system chart of education in Catalonia and in Spain. And these are the ages. Up to 16, there is compulsory secondary education. And in this school, Jesuitas Bellvitge, they are using in baccalaureate and in secondary education, they are using this board to do some prototypes in technology. I teach higher vocational education training, and I use in the first academic year this board, and in the second academic year I use this board. And this is a chart from 2019. In 2020, there was just a new thing, that it was this Master of Vocational Education Training. And in this school, Institut Escola del Treball, they're using these boards just to do the subject of Internet of Things. I teach in a master in the Polytechnic University of Catalonia, just a Master of Industry 4.0, and I do this subject of Internet of Things. And in the Engineers Associations of Catalonia, they do non-formal training programs, and we use this board too. Well, this is the pinout. This is the pinout of the S4A board. And you see here some students doing this prototype. And this is a picture of 2016 in Boston, in the MIT, where we show just this board to work with Scratch for Arduino. Here you have some pictures of the set of peripherals that the students are using: a fan, an edge, a controller for motors, a buzzer, a joystick, a potentiometer, infrared sensors, and servos. And here there is the work of the students. Here I have linked some real questions I do to my students using Snap for Arduino. There are these two parts that are in Catalan that I teach in this language at the school. And here you see just the board being used as a gaming console. We used just to learn how to program this board at the beginning with Snap for Arduino, afterwards with C for Arduino IDI. And these are videos. If you click on, there's a YouTube and a Twitter video of a line follower and sumo fighting. In that time, 2 years ago, the students were able just to mount for themselves all the electronics. It was a little bit messy, and then we designed just another robot that can can carry just a Raspberry Pi 0W or Arduino Nano, and nowadays we are doing these practicals with this another robot. But at the beginning, they learn how to program Arduino using the S4A board. Here, there is an example of a city council of Rubí, a city close to Barcelona, that they wanted to install some sensors just to measure the quality of air. And then one of the requirements was just that the students of the city were able just to read the values of these sensors. Here I am opening this link, and you see just the last values of the sensors. Now it's opening. Okay, anyway, and it is just, okay, now it's appearing. These are the last values read for these sensors. If I want just to see in the sensor 2, I can see which are the values read for these sensors. And here there is the code. If you have interest, you can check how it works. Okay, afterwards I can explain a little bit more if you in the question time if you want. In the Master of Industry 4.0 in the UPC in 2019, we taught Internet of Things with this set. This set has just an ESP32 with a LoRa module just to do communications of Internet of Things, and there is a tactile screen and some relays, and it works with one ESP32, and it can run with a Raspberry Pi 0W. Then in 2020s came the lockdown, and then we were not able to send to the students this set, and I was designing this board that is pretty handy, and then we sent a thing like this with this board. This board is open source hardware. You can find the Gerbers, bill of materials, schematics in the GitHub. If you enter, you can get all the information of the board and even some example codes. This is just the example. I see that somebody has sent a snap here. Then you can have used this code, and it's just a way. This is a digital shell, and this is an UML diagram, and these are the published topics and the sufficient topics that allows the communications between Snap and the board. Here there is the exam that I did to my students. I am opening this, and you will see. Okay, I put this in, and I click the green flag, and you can move the elevator just using these blocks, and even it can be controlled through this board. As you can see, there is some LEDs lighting on. That is when the elevator arrives to a floor, then it is just lighted. And even I can control this. Now I am sending to the floor 0. Now the floor 1, floor 2, and now floor 0 again. And then it's just another way to communicate from this IoT02 board with Snap using MQTT. Okay. Then there is just a spin-off. If you remember, we were very aware of quality of air in our classrooms. Then using this board, I designed it. I changed the sensor of this board for a BME 680 to be able to read the volatile organic compounds, and then you can interpolate with this the CO2 in the air. But it was not so exact, and then we used just a real CO2 sensor. And then based on this design, we do a board like this. I can show through the camera. I don't know if you can see that. And it was just a little bit was big and expensive, and then we did this another smaller version. Then this is my first adaptation of code with the help of Xavier P. This is just the digital shell of this board. If I get the connection, I can see in my lab which is the CO2 now. It's 713 ppms, and which is the temperature just now, and the light level, and these things. Okay, then just to see what is happening inside of this board, I have here a little presentation. This is just the repository in GitHub. You have access directly. This is the schematic of the board. Here you have the CPU, that it is the popular ESP32. You have a light-dependent resistor just to read the light level, some buttons, and a latching relay. This is just the common ESP32. And this is the relay that we are using in Internet of Things. It's just a relay with 2 coils, and it's really convenient because it's not always doing power consumption. In fact, I can change the state with only 3 milliseconds. With 3 milliseconds, I am able just to set this relay, and with 3 milliseconds, I can reset this relay. It's pretty convenient just to read sensors with the industrial protocols. Here I can show you this this board. You can see here a Modbus sensor of temperature, and this is the chip that is able just to read this bus. Here there are some links to explain what is the Modbus RTU and Modbus TCP, and this is the converter we're using in class to convert from USB to Modbus. Because we are teaching Internet of Things, we want just to use LoRa. In Europe, we have the free frequency of 868 megahertz, and this is the module that we put here just in the back side of the board. And there are, as you can see, here we have just a BME 280 sensor that is a voice sensor able to read temperature, relative humidity, and pressure. And there is just an OLED screen. I see some people send this emoticon, okay? And this has been designed using KiCad. Is open source software designing open source hardware. You have all the files in the GitHub if you are interested. This board is programmable with Arduino IDE and with the platform IO, that it's a plugin of Visual Studio Code, VS Code. Here I explain here how to add ESP32 in Arduino IDE. And just to run the code examples, you need to download these libraries. Then if you click here, you can download these libraries, and then all the code examples are running as we expect. Here is just how to program the sequence of buttons. And here there is just an example of how to upload firmware. Okay, here are the steps, and then we are using just a red communications board just to be able to program this board. And this board has some pins that allows to put some extensions. For instance, here we are just putting a full relays board. There are 2 micro switches, and there is just a read relay. And now is time of questions. If you have any question, you can ask to me now.
Where can we find these boards? I'm looking around. Are these basic Arduino boards, or are these ones being the special purchase?
It's not. It's the Arduino IDE is just one of the ways to program this board, but it is not Arduino. It is just ESP32. Is this chip?
Do you have links for these you could share out for these 2 chips?
If I can share the 2 chips?
Yes, it'd be ideal to have a link for being able to purchase these chips. I did find your presentation and your reference to the chips. It's just when I put all the link from the video, it was no longer.
Okay, if you go here, just in view more, then you have just open a new tab, and then you have the IoT 02 board in introduction. And here there is just this PDF,
Mhm.
and you can get here the information of the ESP32 is this one.
And is the other one also purchasable? I believe it was A4A or something like that.
A4A.
The S4A, is that one also one you can procure at this time?
I am sorry, I don't know what is a A4A.
The S4A board, you have two boards that you use in your presentation. And
yeah, this board is just used to control the elevator, and this another one is just to deal with the snap that some of you are using.
maybe we can work out a board, but I'd like to be able to get a link to that.
I am afraid I didn't understand, sorry.
I think you're a bit too fast with your English.
I will
Okay.
point out we have a little under 4 minutes.
Maybe we could try later on, but I'd like to be able to get links to the boards. And it looks like I can't find the S4A anywhere. I did find one from Alibaba, but it looks totally different than your boards. So, but anyway, I don't want to type everybody's.
Those boards are custom made. I don't know if they are for sale. I think that's what they're asking, Jordí, whether you sell these
Okay.
boards.
Okay, this is open source hardware, okay, and there is just a local supplier that is this one that they are doing the manufacturing of this, but precisely because it is open source hardware, anybody is able to do this. In fact, you can see here, this is just the design of the board, and then is this. You have all the files to replicate this board. It's done with KiCad, and if you want just to buy, if you cannot do for yourself this, for instance, in this this local company are doing few of these of these boards. But in fact, I am designing these words for my students, and it's not for sale, but it's open source hardware. And if you have interest, at the end of my my presentation, there is my email, and you can send me if you want any question, and I'll reply. Okay.
Cool. We have 2 minutes left.
More about the elevator. There's a real elevator.
It's only a simulated elevator.
Oh, too bad. Too bad. I've loved elevators ever since I was a kid. I used to find a way to climb on top of them and operate them from riding atop the car. If you can imagine that, what a crazy thing to do as a child.
Mm-hmm. You can do just a prototype of an elevator, and using a kind of board like this, you are able just to move the elevator.
Mm-hmm. Thank you.
If there is not any question else, my next is Bambi Brewer. Okay, good luck, and thank you to everybody. Bye.
Perfect. Thank you, Jordan.